There is a machine sitting at the bottom of the deepest point on Earth right now, a place where the pressure would crush a nuclear submarine like a soda can, where sunlight has not touched the seafloor in 4.5 billion years. But this machine is not a massive steel vessel. It is the size of a briefcase. It weighs less than six pounds. And it does not just survive down there, it swims, it crawls, and it transforms itself to explore terrain that humans may never see with their own eyes. The Mariana Trench, located in the western Pacific Ocean east of the Philippines, plunges nearly 7 miles below sea level. If Mount Everest were dropped into it, the summit would still be more than a mile underwater. The pressure at the bottom exceeds 8 tons per square inch, the equivalent of 50 jumbo jets stacked on top of a person. The temperature hovers just above freezing. And yet in March of 2025, researchers from Beihang University in Beijing published a paper in the journal Science Robotics that sent ripples through the engineering world. They described a miniature shape-shifting robot that operated successfully at 10,666 meters, deeper than any small-scale unmanned craft has ever gone. What makes this even more remarkable is what the robot does with all that crushing pressure. Most machines treat extreme depth as the enemy, something to be resisted with thick titanium hulls and reinforced joints. But this robot does the opposite. It converts that pressure into power. The technology behind this is called a shape memory alloy, sometimes known as smart metal. These are special materials, typically made from nickel and titanium, that can remember a specific shape and return to it when heated. Bend a piece of this wire into a ball, toss it into hot water, and it springs back to its original form almost instantly. The Chinese team figured out how to harness this phenomenon in the deep ocean, where the cold temperatures and immense pressure actually enhance the alloy's performance rather than hinder it. Pan Fei, the study's first author, described it this way: the material structure transforms external high pressure into enhanced speed and amplitude for the actuator, turning what should be a weakness into an asset. In other words, the deeper the robot goes, the faster and stronger its movements become. At a depth where conventional machines fail, this one thrives. The robot itself looks unlike anything previously deployed to the ocean floor. Inspired by the batfish, a strange, deep-sea creature that walks along the seabed using modified fins rather than swimming, the 50-centimeter-long device can shift between multiple modes of locomotion. It has legs for crawling across rocky terrain, symmetrical tail fins for swimming through open water, and folding pectoral fins that let it glide through the water column like an underwater bird. By mechanically reprogramming its limbs, it adapts to whatever environment it encounters. Professor Wen Li, the chief researcher who began this project back in 2019, put the accomplishment into perspective with a striking analogy. At a depth of 10 kilometers, he explained, the pressure is equivalent to a robot bearing the weight of an iceberg. Most machines simply cannot function under those conditions. Conventional submarines, even military ones, operate at depths measured in hundreds of meters, not thousands. The United States Navy's most capable research submersible, Alvin, can reach 6,500 meters after a $50 million upgrade, but that is still more than 4 kilometers short of where this tiny Chinese robot successfully completed its mission. Could this robot be the key to unlocking secrets we have never accessed before? Is this the beginning of a new ERA in deep-sea exploration, or is there something else at stake here entirely? Drop a theory in the comments. The timing of this announcement matters. While China has been pouring resources into deep ocean technology for over a decade, the pace has accelerated dramatically in recent years. Consider the numbers. In 2024 alone, China completed 246 deep-sea dives, more than every other nation on Earth combined. The country now operates 3 major crewed submersibles: the Jiaolong, the Shenhai Yangshi, or Deep Sea Warrior, and the Fenduje, or Striver, which together have logged more than 1,700 dives since their commissioning. The Fenduje alone has descended below 10,000 meters 25 times, a feat no other national program can match. Meanwhile, the United States relies heavily on Alvin, a submersible first launched in 1964. While Alvin has completed over 5,000 dives and made historic discoveries, including the RMS Titanic wreck and the first hydrothermal vents, its age shows. The vessel only received clearance to dive to its current maximum depth in 2022, more than 60 years after its first deployment. The miniature robot from Beihang represents something different, a new approach that could upend how nations explore and exploit the deep ocean. Rather than building larger, more expensive crewed vessels, the Chinese team created something small, cheap, and bendable. The entire robot weighs 2.7 kilograms and fits inside a briefcase. It requires no human pilot, no massive support ship, no billion-dollar infrastructure. It can be deployed from existing submersibles using their robotic arms and retrieved after completing its mission, fully intact. During field tests, the robot operated from 2 of China's most advanced crewed submersibles across 14 separate seabed expeditions. It was released onto the seafloor at the Haima Cold Seep at 1,380 meters, and at the Mariana Trench at more than 10,600 meters. Each time it worked for more than 20 minutes before being retrieved. At those depths, the robot achieved swimming speeds of more than 5 centimeters per second and crawling speeds of 3 centimeters per second across sandy surfaces. The question is why this matters, beyond pure scientific curiosity. The deep ocean floor contains something the modern world desperately needs. Critical minerals, vast deposits of manganese, cobalt, nickel, and rare earth elements carpet the seabed in regions like the Clarion-Clipperton Zone, between Hawaii and Mexico. These materials are essential for manufacturing everything from smartphones and electric vehicle batteries to advanced weapons systems and satellite components. Right now, China controls the global supply chain for most of these minerals. A first-mover advantage in deep-sea mining technology would cement that dominance for decades to come. Beihang University itself is no ordinary academic institution. Founded in 1952 by merging the aerospace departments from 8 elite Chinese universities, including Tsinghua, it was China's first institution dedicated to aeronautics and astronautics. Known as one of the 7 sons of national defense, Beihang has produced China's first light passenger aircraft, its first sounding rocket, and its first unmanned aerial vehicle. The university's researchers have earned over 1,200 national-level awards for scientific achievement. Now they have turned their attention from the skies to the ocean floor. The robot's soft actuator, a flexible component that drives movement, weighs just 16 grams and measures only a few centimeters across. It incorporates something called bistable chiral metamaterials, engineered structures that can snap between 2 stable positions when pressure is applied. By combining these with tube-sealed shape memory alloys heated by periodic electrical currents, the actuator generates rapid oscillations even in near-freezing temperatures. The harder the surrounding water pushes against the robot, the more energy the system stores and the more forcefully it can move. One of the most significant capabilities demonstrated during testing was the robot's soft gripper attachment. Mounted on a submersible's rigid robotic arm, this gripper successfully retrieved delicate specimens from the South China Sea, including sea urchins and starfish that would have been crushed by conventional metal claws. For marine biologists, this represents a breakthrough. The deep ocean hosts ecosystems we barely understand, creatures that have evolved in complete isolation for millions of years. Traditional sampling methods often destroy the very organisms scientists want to study. A soft, pressure-powered gripper could change that. What makes the engineering particularly elegant is how few compromises it requires. Most deep-sea robots must carry heavy pressure-resistant housings to protect their electronics and motors. This design uses components that are inherently incompressible, materials that function the same whether they are at the surface or 7 miles down. The robot's battery, controller, and shape memory alloy springs all operate without any need for protective chambers. The ocean itself becomes part of the machine. The research team has already outlined plans for the next phase. They intend to mount cameras, sensors, and buoyancy devices onto larger prototypes. They are exploring how artificial intelligence could enable the robots to navigate and collect samples autonomously, without any human guidance. They are investigating how swarms of these small robots could work together, covering more territory and gathering more data than any single crewed submersible ever could. But there is a strategic dimension to this work that extends far beyond scientific exploration. The Mariana Trench sits in the western Pacific, roughly 200 kilometers from Guam, a critical American military outpost and gateway to what strategists call the second island chain. Understanding the acoustic properties, thermal layers, and underwater terrain of this region would give enormous advantage to any navy seeking to operate there. Submarines rely on the deep ocean to hide, and the nation that best understands the deepest waters holds a significant edge. China's Institute of Deep Sea Science and Engineering, based in Sanya on the island of Hainan, explicitly ties its research to both civilian and military objectives. The deep sea environment offers not only scientific treasures, but also potential hiding places for nuclear-armed ballistic missile submarines, pathways for underwater communications cables that carry 90% of global internet traffic, and vast reserves of resources that could reshape the global economy. The tiny robot from Beihang may look like a science project, but it represents something far more consequential, proof that China can engineer systems capable of operating in environments that remain effectively inaccessible to most other nations. Where American researchers see limits, Chinese engineers see opportunities. Where Western institutions debate the ethics and economics of deep-sea exploitation, Chinese teams are deploying hardware to the bottom of the world. Yet for all its implications, the achievement also represents something genuinely inspiring. For most of human history, the deepest ocean trenches were as unreachable as the surface of distant planets. The first human descent to the Challenger Deep happened in 1960, when Jacques Piccard and Don Walsh spent just 20 minutes on the seafloor before having to ascend. Since then, fewer than 24 people have made the journey. But a small team in Beijing has built something that could go there anytime, stay as long as its battery lasts, and come back to tell us what it found. The deep ocean remains Earth's final frontier, a place where the rules are different, where life has taken forms we can barely imagine, where the pressure itself becomes a kind of physics we are only beginning to understand. The question is no longer whether humans can reach those depths. The question is, who will get there first? Who will stay the longest, and what they will find when they arrive. A briefcase-sized robot that turns crushing pressure into power may be the first clue to the answer.